A new series to start here in the community call frequency architecture series. So this is part one of the frequency architecture series, and I really want to use this as a way to help people kind of grasp what the basic concepts are, how to think about the data structures and the interactions that happen on frequency so that it's really easy to kind of pick up and understand the documentation as a whole. So with user and identity on frequency, we really start off with just one little thing. A 64-bit identifier, this little tiny thing, a snowflake of uniqueness, and that is identity on frequency. Now, obviously, that's not everything about identity on frequency, but we usually refer to this as an MSA ID. But at the end of the day, it's this little tiny 64-bit identifier that sits on chain, and that is the permanent identifier for that identity inside of frequency. Now, some people might actually be asking, especially if you're used to working with identity in other blockchain environments, why not use a public key, which is a much more common source of uniqueness? And there's a couple of reasons for that. One of them is just pure data storage. So a 64-bit identifier is much smaller than a lot of the other public keys you see on chains like in Ethereum are 160 bits. And while that doesn't sound like much, it's more than double the amount of size. And so when we start using this identifier all over the place, that size really starts to matter. However, it's also true that a 64-bit identifier isn't just the end of the identity, right? So we take a couple different things. So one of these is, how do you kind of manage this 64-bit identifier? How do we know who actually is the identity behind the identifier? And so for that, we have control keys. Those are keys that are attached to the 64-bit identifier, and they manage whether information about that identifier, they are the authorization that is held by a human or a computer that actually controls that identifier. We also attach other unique kind of special information to this. Handle is a good example of something that needs to be unique. It has a unique data structure. It matters, right? We can't have two 64-bit identifiers having the same handle to keep that handle unique. And so we have this kind of small set right now of control keys and handle that are very much unique and special for that 64-bit identifier. I'll also note here one of the other advantages of having control keys that are separate from this identifier is that those control keys can get changed. You can have multi-key setups. You can rotate keys. You can have cold wallets controlling things. Provides a lot more of that security while still maintaining that anchor of an identifier. So that's kind of this ball of uniqueness we have, but we can keep going a little bit farther, right? There's a lot of other data that ends up attached to a user to an identity. We have things like social graph, public keys for encryption, token addresses, profile. These are all things that are user indexed, meaning if I usually want to look these things up given that I have a user. Sometimes, right, there's the case where it's like, oh, I'm searching for a profile and things, but usually I have that 64-bit identifier, and so I can look at what's connected to that 64-bit identifier, and I can say, oh, okay, there's the social graph, there's the public keys, there's the token address, there's the profile. Those are all connected to that 64-bit identifier, and primarily they're indexed on that user. Now, in frequency, these are often stored inside of the actual data for these is stored inside stateful storage. So that stateful storage kind of main is where the social graph lives and public keys, token address, but some of it, such as profile, contains external content, user content that we don't want to be stored on chain for lots of different reasons, but size is an easy one of those. So that profile we actually take and gets it's actually just a pointer to decentralized storage, such as IPFS. Doesn't have to be, but usually when we have things that are referenced off-chain data that's referenced on-chain, right now that's all pointing to decentralized IPFS storage. So that gets a lot of things, and I bet a lot of people are thinking, oh well, there you go. That's the sum of a user and their identity, but it doesn't end there. So we can take a look at other things we have. So users also have things like social posts, there's replies, there's content attributes. There's this whole kind of bundle of things that instead of being user indexed, tend to be time indexed, right? Whereas I look for a user and then I want their more or less singular kind of profile or their social graph. When I'm looking at social posts, I'm looking at many different users' social posts. If I'm looking for attributes and attestations, I'm kind of looking for larger bundles of things. So these things are time indexed and they also can point to each other as well, right? So, right, if I have a social post, it's a replies to that content attributes. All of those things then also can point at the identifier. So we can, given a social post that was indexed on time, I can then look at that post and see, well, who actually is this associated with? And imagine this, what's their profile, right? So you can start to see kind of this flow of like, oh, there's this data that we have that is mostly kind of centered, it's special, it has uniqueness around it. We have data that's user indexed, that's stored either on chain or referenced data off chain. And we have this time index data that is indexed by time first, and then itself references that 64-bit identifier. But again, like the profile, these things don't always end up just uh, being data that's on chain. They also, of course, usually end up having additional external data that's sitting out there in IPFS. So we have this kind of bundle of how on frequency we start thinking about identity and uniqueness, how we think about data being attached to it. We have this time index and user index data. I mentioned user index data is often sitting inside of stateful storage, which is storing information on chain or references to off chain data that is indexed to the user. We also have message data that tends to be time, and that's the time index data, and that's those social posts and stuff. So we actually have different storage mechanisms for them, but they all follow into and kind of point in some way either from or back to those user 64-bit identifiers. So that's the kind of the big thing. Next time, we're going to be talking about applications in the architecture part 2 and start to see, well, okay, now that we have a user and how user data looks like inside of frequency and some examples of that, how the applications themselves kind of start interacting with users and that user data.